welcome to GeoTalks Express for the month of April, and to this session titled Lidar Tips and Tricks. My name is Jeff Hatzel. I'm a product manager here at Blue Marble, and today I'm joined by my colleague who is an application specialist here, Nate. How are you doing today, Nate?
Doing great. Thank you for being here, everyone. Excited to talk about Lidar tips and tricks.
Yeah, I think this is going to be an interesting session for everyone today. Nate and I were talking earlier, and since we started GeoTalks a couple of years ago, some of the sessions where we get the most feedback and excitement are ones where we dig into a little bit more of those hidden or less popular features within the application. And so that's what we're going to do today for this session, all focused one way or another around Lidar data and point cloud type analysis. So Nate and I are going to go back and forth, work through a variety of workflows. We're really today going to look at less known tools, right? So, for some of our other webinars and videos, we look at all our big popular features, automated classification, the pixels to points tool, and things like that. Today, we're going to dig down a little deeper and look at some of the things we don't always get a chance to look at, given the vast amount of functionality that Global Mapper has for us. So before we get into things today, let's just take a quick second to go over the format of the webinar today. Nate and I were talking, we see a lot of familiar names on the attendee list today. So many of you are probably familiar with how this goes. For those of you who are new, you will be in listen-only mode today, so you can hear us. We cannot hear you. However, we encourage you to reach out through the questions panel in the GoToWebinar sidebar. So please feel free to send your questions through. Those that we can answer live, we will. We make no promises while we're talking and demoing here, going back and forth. If we can't get to something live, all the questions will be answered after the webinar. You will, I believe, get a direct answer to all your questions via email, and then we post the questions and answers as a whole to our blog, usually a week or two following the webinar. So one way or another, we will do our best to get you an answer to your questions. And this session is being recorded, so once that recording is complete and edited and everything, it will get up on our YouTube page as well. So anybody signed up here today will be alerted of that once it gets posted too. Newer to our GeoTalks Express is we have a handout attached to this webinar, and so you can find that in the handout section of the GoToWebinar panel. Today, that's just a one-page PDF, generally a little outline and summary of everything that we're going to look at. Importantly, though, it has links to all the associated tools, so you'll be able to click the link in the PDF and open the associated documentation page. Especially since today, we're going to go through a lot of things quick. This isn't really a training, and you may want to read a little bit in more detail about some of the functionality that we look at. We have a couple other GeoTalks planned for the remainder of the first half of the year. So in May, we're going to be looking at coastal flood analysis in Global Mapper. And then I will be back in June and we'll be discussing Global Mapper Mobile and maybe a little bit about what's coming for the next Global Mapper Mobile release. You can always stay up to date with that from the GeoTalks Express page on our website. We have a few training classes planned and on the horizon as well. So the next 2 weeks, starting next week, I believe, we have a Global Mapper training class, and the following week, a Lidar processing class. So if you are someone who is looking to further your skills in Global Mapper or with Lidar analysis, or you see something today you want to expand it upon, those classes will be a great option for you. In early June, we have a applied geodesy and geographic calculator training. So if you are also one of our geographic calculator users, or maybe you work more heavily in the geodetics side of the geospatial industry, I strongly encourage you to attend that course. It's always a very informative course. It's led by Sam Knight, our Director of Product Management, and he does a great job with that course. Late June, we have another global mapper and Lidar processing, a week for each. And then we also have coming up a French language training. So if we have any of our French users here and you want to take a training in French, that is middle end of June. Take a look for details on that. Will be on our website, and I believe that is actually being hosted through our French reseller. So take a look for details on that, if any of that is of interest to you. One last thing to note before we get into today, we are, feels like finally, back on the road and traveling. One of our colleagues this week, actually today, is at GIST in Charleston, South Carolina. And we have a whole slew of events on the docket for the remainder, at least of the first half of this year. So if you're in any of these regions and want to stop by and see us, please feel free to do so. Before we get into our agenda today and hop over to things, I want to throw up a poll quickly here. So please go ahead if you have a second to answer this poll. You should see it now live, it's open. Just to give us as speakers today a better understanding of how everybody is utilizing, if they are utilizing any LiDAR point cloud analysis within Global Mapper. So we'll keep that open for just another couple seconds here as I can see people are still submitting their responses. It looks like
hopefully
right now,
this webinar, I think it's great because folks who have a lot of experience with the LiDAR processing tools in Global Mapper, or if you're new to LiDAR, I think hopefully there's some new content for everybody.
Yeah, that's a great point. Even right now, I'm looking at the early poll results, and it looks like the majority of people, mentioned using terrain analysis, right? And even today, we're going to look at some more, unique little aspects of terrain analysis within the application. So I think you're right there, Nate. Okay, it looks like things are slowing down on the poll. About 80% of us have voted. So I'm going to go ahead and close this and share it up here for a second so everybody can see the results. Again, pretty strong in favor of terrain data analysis with a good split between then vector feature extraction and data QC. Really some good use all over the board there. Even a few people who aren't yet using Global Mapper's point cloud tools. Hopefully today inspires you to take a look at those. And at that point is a good segue. So let's talk a little bit about where we will be going today for this session. We're going to start by looking at some ways that we display LiDAR, or unique ways we can look at LiDAR. And that'll cover looking at custom shaders and different ways of applying color to a point cloud. Nate's actually going to walk us through a really interesting applying color workflow, one that I hadn't seen before until he showed it to me for this talk. So I think that's going to be a really neat little bit of analysis. We'll talk about some advanced filtering and editing. Not always, but very often we need to get hands-on with our LiDAR data, for whatever our goal is, and how do I want to maybe dig in and clean things up or query things and search for features. So we'll look at some of the ways we can do that. We'll talk about different ways we can work with traditional vector data in relation to a point cloud we may have loaded. Talking about maybe some building footprints, and we'll talk about some some water bodies and things of that nature, before getting into the profile viewer and some of the newer and a little bit more buried features in the profile view. And time permitting, we'll then go ahead and wrap up with looking at creating a mesh from a point cloud. So meshes or 3D models are very often used not only for visualization purposes and modeling in Global Mapper, but very often we have users who are taking those features then into their next graphic design software or whatever it is that they may be working with. And so within many of these workflows, we'll be looking at even smaller subsets of functionality, beyond just what we have generally listed at this bullet here. Nate, anything I'm forgetting before we go ahead and get started here?
No, I think that looks pretty good. Yeah, just hopefully time permitting, we can cover some of the hidden processes at the end of the session. But,
yeah, always so much to cover and never enough time.
That's right.
Okay, but let's go ahead. We'll take a look at our first workspace here. This is a Lidar scan of the Devil's Tower Monument in the Western United States. And right now we're viewing this by elevation, and that's probably by far the most popular and most familiar way we look at point clouds, short of maybe viewing it or coloring it by classification. If we take a look at it in the 3D view, very often this is a familiar perspective to us, right? We can see the full 3D surface, or I shouldn't say surface, but 3D point cloud here, and the features that that point cloud represents. For those of you who are familiar with Global Mapper, you might notice that I have a different background set in my 3D viewer here. So by default, our background, I think, is usually the cloudy light rays. And there's a variety of other options from this dropdown. But I generally prefer to keep a black or a solid background when I'm working with Lidar. Very rarely am I going to have a large amount of black points on my screen. So I find that it helps my colors and things pop much more efficiently, especially when I'm getting into some in-depth analysis. We can always change this black color. So from our Lidar, or excuse me, our 3D view configurations, under the environment option, I could change that background color. You can make that whatever you want. Another important setting here I want to highlight is a setting called iDome lighting. We added this to Global Mapper maybe a version or two ago. What iDome lighting does is it helps to give us a little bit more detail in the lighting of our features in 3D. So this would apply to a terrain layer as well. But for right now, we're looking at it in the context of Lidar. And so what I want us to notice is especially off in the distance, how I can very clearly see my features. But I can see that there are trees here off in the distance. Up close, I can very clearly see shadowing around individual trees and features of the landscape and the surface, all thanks to that iDome lighting. Now let's watch what happens now when I turn off my iDome lighting. This scene looks much flatter and much smoother and much less detailed. It's harder to see individual trees. I don't really have any visualization here of the terrain features. We saw some maybe crevices or runoff features. We don't see that at all any longer. And often the distance really just looks like a plain point cloud here. So iDome lighting, especially if we're looking at smaller features, things like trees. I've seen people use it for finding windows, hay bales, smaller features that don't necessarily stand out without a little extra shadowing, really pop as part of our visualization process here. Let's go ahead and continue looking at this point cloud in 2D. So I'd mentioned, looking at our point clouds by elevation or classification if they're classified, but there are some less common display methods that I think are important for us to be aware of. If we think about point density, and point density being the number of points in the point cloud in a given region, visualizing by point density lets us see, a couple things. And I think the important takeaway here is this lets us really see our flight paths. And if I had to guess, I would say my flight paths probably fly right over these two areas with a lower density. As our Lidar scanner scans from the aircraft, if there's two flight paths, we're going to have some overlap. And where that overlap exists, we're going to have more points, which naturally leads us to have a higher density in those regions. So if we were concerned with where our flight paths occurred, great way to start to get a feel for that, looking at our data by density. Another way that we can maybe confirm that is viewing our LiDAR by scan angle. So the scan angle is literally the angle of from the sensor to the ground surface when the light pulse left the LiDAR sensor. And so we can see here, the blue values are a very low scan angle. So the aircraft probably followed these blue strips. And then obviously as the angle increased, these are also the regions where we saw more density because both aircraft were scanning in that area at the larger angle. It stands out even a little bit better as we zoom in there. The last thing we'll look at here, maybe not quite as uncommon, but important nonetheless, is viewing a point cloud by intensity. Intensity essentially represents the strength of the return of the laser pulse back to the sensor. So it hits a surface on the ground or whatever the case may be and returns to the sensor. The strength of that return is called intensity. Now we'll see, right, very easy way for us to visualize certain objects, right? My trees, I don't even need to zoom in. I can see my trees are much darker than the remainder of the landscape. We can very clearly see our road feature that leads into the park. Somebody asked where this was. This is Devil's Tower National Monument. I believe that's in Wyoming in the Western United States. We can see, our ground surface, probably grass out here. Water is another very common thing we can usually see clearly with intensity. There's no water bodies here, but a whole variety of ways that we can work with something just as simple as viewing our point cloud to begin to get more information from it. For those of you who have attended or will be attending our training, in that training, we'll even talk about how intensity can be used in some of the new semantic segmentation methods, and we think about identifying features in the point cloud. But okay, we've done a bit of talking. Let's go ahead and take a look at creating a custom shader. So I'm going to go back and color my point cloud by this first option, RGB or elevation. If there's color, RGB, it'll show it by color. If not, it will show it by elevation. What we're going to do right now is choose to add a custom shader. And in this case, I'm going to do this from a shader file that already exists. And I'm going to add one more value. So this stops at 20 meters. I'm going to add a value and a color of 40 meters. Oh, just got to give it a new name. Now we'll see that's also applied to my data set, so I can see my elevation shader now goes from that green to brown to the whites at the highest elevations. I can take a look at this in 3D view, and with our eye dome lighting, we now have a whole nother perspective of our landscape. Very often we use custom shaders if we're maybe measuring difference values or changes over time. Custom shaders are a great way to isolate and visualize things of that nature. Now, I had mentioned here that if we had RGB information in our point cloud, we could visualize it that way. Many of the newer LiDAR scanners have the ability to record RGB in association with the points. So if you were to look at the info for any given point, in addition to the standard attributes, you would also have a red, green, and a blue value that correspond to the color for the given point. Now, in this case, we don't have that. What we do have, though, is imagery that overlays the same area. And what we can do is apply color to the point cloud from the imagery in relation to the pixel that the point sits on. And this is a very quick process. We choose our point cloud, we choose our imagery, and then what type of color we want to add, how many bands we want to add. That'll take just a second to run. And then when it completes here and redraws, it's probably going to look like we can no longer see the point cloud. Since I added RGB, the color option now shows it as RGB. So if I shut off my imagery, I can zoom in now and see these are actually the individual points, but shown based on that color value. This becomes incredibly helpful when we think about viewing our data set in 3D and how we get a much more true to life picture of what we are working with. So if we're doing something like creating, visuals or outputs or videos of this, having color as part of that point cloud really can be beneficial. So one other quick thing I want to show there. I'm going to zoom in a little bit, and we'll notice that when I open my 3D viewer, I don't see any more data than what is loaded currently in the 2D view. So my 3D bounds are just automatically clipped to my 2D extent. I'm doing this now, right, just for the sake of performance, while I'm also streaming this webinar and recording it, and I have a lot going on. So if you're, excuse me, ever in a scenario where you need to help improve performance, or maybe you're just working with a massive point cloud and you don't need to see the full extent of the point cloud, configuration settings for 3D, there's an option in here to mask 3D by the 2D bounds, and that's what I have enabled. Okay, Nate, I think what we'll do now is let you talk to us about another little bit more detailed and exciting color workflow with LiDAR data. So let me send this your way, and the screen should now be yours.
All right, thank you very much. Always a really interesting thing, I think. So this data set that we are looking at right now comes to us by way of Dr. Van Leeuwen, who is the director of the Arizona Remote Sensing Center at the University of Arizona. And what we're looking at is a pecan orchard. So still in the Western United States. This is in southeastern Arizona. If you're not familiar with the area, it's a very arid and very hot climate. So if you're involved in agriculture, very careful and I guess I'll say judicious water management is going to be really critical. So for LiDAR processing, as far as applications in precision agriculture, it's going to be very helpful to be able to identify crops or trees in an orchard that might be suffering from water stress. And we can do that using the tools of multispectral imaging. So the data that we have here comes from a multi-spectral sensor that was mounted to a drone, and that can then collect different bands, what they're called bands, essentially segments of the electromagnetic spectrum, these bands of light that are reflected off of different features of the surface where the drone was flown, and then captured, split up essentially and captured individually by the sensor. To give folks a little bit of a better contextual sense of what that looks like. Oops, make sure that these are coming off here. Folks who might be familiar with pixels to points, basically what we had here was a series of images, and each image was captured, or I should say each band was captured at the same time that any image of the drone was taken. So what you get is, for example, here, the images representing those red reflectance values. We can see what a particular image looks like with red. And then if we look at it again, the same image, the corresponding image in green, those intensity values look a little bit different. And so basically we do that. It's split up into 5 different bands, red, green, and blue. So color, visible light, as well as near infrared and an additional band called red edge, which we will not be talking about too much today. But essentially what we did was with our 5 different layers of picture points, we then run a pixels to points analysis. And what we get as a result of that are 5, or I guess I should say 10 really, different data products representing our different bands of light. So we get ortho image representing the red, the green, followed by the blue, and the near infrared. And then these are our 2-dimensional ortho images. In addition to this, we get the corresponding point clouds that also then, as you can see, we have currently our Lidar drawn by RGB. Right now, those RGB values represent these grayscale band intensity readings. So I can go ahead and look at this in the 3D viewer to give a little bit of a sense of what that looks like. So Pecan Orchard here looks like it's just kind of in grayscale, sort of like that intensity shader that Jeff showed us a second ago. But now what we can do is, even though it doesn't look like we have any RGB values, we can apply colors to our point cloud rather than just taking that from an RGB, a raster, or I should say a satellite image or something represented in true color. What we're going to do is add each of those bands separately. So I'm going to come back here to the Apply Color to Lidar Points tool. And this time, instead of updating just the RGB fields, what we want to do is add RGB plus that extra near infrared band. We're going to want to make sure that this is in 16-bit. And so we're going to be applying this to each of our point clouds that we got from our pixels to points analysis, and parsing those, splitting those up based on the corresponding band image layer representing a particular band of light. That's going to bring us, it's okay, not everything's covered by an image layer, that's all right. That's going to bring us to our band setup. So from here, it's asking us, what do we want to choose for the red color channel? We're going to select red. Makes sense. Same thing for the green color channel, we're going to want to select green. And for blue, the same thing, I'm going to select blue. This isn't how you have to set it up. You can mix these around a little bit, and in the output, you'll get some false color imagery, which does have its applications as well. It can help certain features stand out in ways that they might not with the kind of more true color representation. But now, when I click OK, we are still coloring by RGB, but instead of the band intensity grayscale that represents color, if we draw our point cloud by RGB, we're going to get a little bit closer to that true color representation of our pecan orchard. So we'll have a look at that, and we should be able to see now. Our tree leaves look like they're pretty green. We do have, looks like it's a little out of focus in between. Mostly that's because we ran our pixels to points 5 separate times. There's a little bit of misalignment, a little bit of mismatch from the underlying ortho imagery. In a real world application, we would probably want to make sure that we rectified those ortho images with some ground control points before we did that. But for our purposes, this works. And we've got a couple other built-in shaders that we can use to visualize our data set here. We know we passed that near infrared channel in. So one we can look at is this color infrared, which is going to let us visualize those intensity readings, but with a nice kind of colored shader here, these reddish sort of hues. And then another really interesting application, users who have done the global mapper training will probably note, of course, we passed in the red light and the near infrared light, and those are the two bands that are needed to set up what is known as a NDVI, that's a normalized difference vegetation index. In broad terms, essentially a greenness index of plants. So the greener a plant is, the higher its NDVI value is going to be. So instead of having to set up a raster calculator, as we would have to do were we working with raster imagery, when we have applied those RGB plus NIR bands into our point cloud, we can just go ahead and use the built-in NDVI shader, and Global Mapper will do all of that calculation sort of under the hood, and we get this nice NDVI representation of our surface here. We can look at this in 3D again. That gives us the benefit of looking at this from some different perspectives, and we can make out with that item lighting individual trees. And what we might also want to do if we were running some sort of analysis on the health of our orchard here would be to grab the feature info tool and just have a look at some of our points here in our point cloud. In this particular point representing a certain leaf on this tree over here, we've got an NDVI of about 0.37, which I think for the scale that it looks like maybe a little bit low. So maybe this tree needs a little bit of water, maybe it has a little bit of root rot. Hard to say, probably want to do a little bit of investigating at that point. But that is using the apply color tool on a point cloud to look at a couple of different color values in NDVI.
Yeah, that really is just a really cool use of the apply color tool, I think.
Yeah, one of the kind of lesser known, that's sort of what the webinar is dedicated to, just some of these settings that are kind of hidden a little way. But
do you want to tell us a little bit about LiDAR filtering and LiDAR editing while I have your attention here?
Yeah, let's do that.
Okay.
That's great. So for this, we are, perhaps for some attendees of our webinar here, in a fairly familiar location. This is Hawley, Minnesota. It's a town that we have spent quite a bit of time in our trainings, as well as some other kind of demo workflows that we've done in the past. Right now, again, we're looking at this by RGB elevation. We do not have those RGB color values applied to our points, so by default, it's showing us how this looks by elevation. We can also go ahead and look at this colored by point classification. So what different sorts of features on the ground these points are going to represent. I'm going to zoom in just a little bit here. There we go. And you can make out, looks like we've got these buildings here in orange, the ground kind of represented in this brown color. We've got some vegetation here, and these pink stripes representing overlap, which talk a little bit more about that in a second. If we wanted, though, we could further subset our point cloud here beyond what the built-in classification options are. So for example, all of our buildings right now are represented with the same class, but if I wanted to further subset this so that I had all of the buildings that were above or below a certain elevation, we could use a vector searching query to do just that. So what I'm gonna do first is, oops, do I have the cursor here?
You should, yep, I think you
Oh,
do.
there it is. Okay, come back to the full extent, and what I'm gonna color the point cloud by now is height above ground. This works because we have our ground classified points here, so it's gonna essentially establish all of those as the base elevation and give us the elevation values for other points, non-ground points, relative to the ground points beneath them. So when I do that, we can see a little bit more of how that looks. Those buildings look like they're kind of starting to stand out, maybe a little bit more. And so what I'm going to want to do now is come up here to the search vector data command. Lidar data is, these are point features. This is technically vector data, so we can use this vector searching tool for this. I don't think we need to sort this right now necessarily. I think we can just go right into the query. There it is. So come bring this in a little bit closer. And so in this case, what I think we would like to do is find all of our buildings that are above, I'll say right now our elevations are represented in meters. We'll say 6 meters, and we'll call those tall buildings. So the first thing I want to do is make sure that we're only searching for those buildings. So the first attribute that I'm going to use to subset our data is the class. So I'm going to go ahead and select the class and tell it that I want to search points that have a class, load the existing classes we have in our point cloud here, and want to make sure that we're only searching for buildings. So this first portion of the query is going to look for all of the points in our point cloud that are classified with the number 6, which represents buildings. And then we're going to want to further subset this to only get the building points that are above a certain elevation. So I'm going to use an AND operator there. So that's going to further subset or exclude other building points that are below the threshold that I want. And I'm going to select where the height above ground is less than, and again, I'm going to choose 6. That's just an arbitrary value that I'm choosing where I say a building that is above 6 meters tall is in its own special class of tall buildings. I'm going to validate this and make sure that that query is going to work. This looks like it's good to go. And I can go ahead and click search. As it's searching through this, those subsetted points are just going to appear here in the attribute editor. Once that's done, we've got a couple million points here, so it's just making double sure that we're finding all the points that we need. So what we can now do, because those are all represented here, is go ahead and select all of them. In the window, you'll see we've selected quite a few buildings, but not all of them. And, oh, sorry, I did this backwards. When I wanted points greater than 6, and I said I wanted less than 6. I thought it looked like there were too many there. So I'm going to do this really quickly one more time, make sure that I'm getting the tall buildings, not all the buildings that are less than 6 meters, which is going to be more than I need. And fewer points to have to find out, so it should go a little quicker. Now we've got those here in our attribute editor, and I'm going to select those. That looks more like what I was expecting. And so now what I want to do is, I'm done with our search here. I've selected those, so now I can just go ahead and copy and paste those into a new layer. which I am going to call, oops, tall buildings. We'll click OK. And we should now see here in our control center, once that's done loading, I can go ahead and turn this off. And we should see just those tall buildings. Go ahead and clear my selection once that's done too.
And it's worth noting, Nate, that I didn't hear you say this, excuse me if you did, but anytime you make a query like that, you can always save it and reload it, to be used another time.
Absolutely, yep. So if we turn off our original point cloud for all of Holly, now we can just see just those tall buildings that I wanted. These are still classified as buildings though, so one more little tip and trick that we can do is to give them a new class, a custom class that's not part of the built-in list of LiDAR point classes that you get when you download Global Mapper. So what I'm going to do is select all of these points. Should be clicking and dragging. That's all right. What I'm going to do is select them from the control center. And then first thing I'm going to want to do is create the class itself. I don't actually need my attribute editor anymore, so let's close that. I'm going to create the class itself that we want to add them to. So we've got a couple of built-in class definitions here, but we can, with all of these ones that say reserved for ASPRS definition, we can create and customize and modify new ones. So with Jeff's permission on his computer, I'm going to grab class 22. And first thing I'm going to do is set the class name. So I'll go ahead and call this tall buildings. And now we want to make sure we give it another color so that it can be differentiated from the regular buildings. So set class color, maybe a nice sort of blue, purple, gray, I'm not sure. Something like that looks good, I think. I'm going to click OK. That's going to save that class definition to that list. And now because these are selected, I can just really quickly manually reclassify them into the new classification, which should be, oops, a little too far there. 22 tall buildings, just like I set it up. Click OK, and really quickly, we should get those points when I look at them, colored by classification. I'll go ahead and turn the rest of Holly back on, and we should now see those with a different color scheme now that they have a new class. Final thing before we move on from Holly to the next portion of the webinar is I mentioned earlier these two pink stripes here representing overlap. And Jeff alluded to this a bit in the beginning when he demonstrated those point density and scan angle LiDAR draw modes. Same thing is going on here. This is basically where those successive LiDAR scans from the aircraft overlapped. So we've got higher point density here, and that can be helpful for as a reference point, but it's really not going to be helpful for us to, if we want to then do analysis and create a terrain grid or do some vector extraction. Points classified as overlap don't really help us too much. So we're going to do another method of LiDAR filtration to go ahead and change those. So what I'll do now is again color by classification. I'll go ahead and turn off my tall buildings layer. I'm going to select all of the points in Holly. Those are now selected, and what I can do now is come to advanced selection here and filter my selected LiDAR points. And what I want to do now is just make sure that the only ones that I am visualizing, or selecting rather, is class 12, which is overlap. So I'm going to make sure that's the only one. And when I click OK now, we should get only those overlap points selected. So once again, we can come back to our automatic or excuse me, manual rather, Lidar reclassification tool right here. This is only going to apply to those selected points, and I'm going to leave those in an unclassified state now, which then makes it possible for us to reclassify them into the appropriate class more accurately and easily. So if we look at this now by display, we can see those are no longer classified as overlap. Those are just unclassified points. So one thing we could do now would be to automatically classify those within that overlap, which are not all ground points, but we would probably want to start by just determining which ones are, because that's going to help us if we want to construct a terrain model or do some, elevation analysis where we need those ground points as a base reference. I'm just going to go ahead and leave these parameters in the default state. And let's just go ahead and make sure that we are only running this analysis on our unclassified points here. So classifying only these unclassified points, click OK, leave our parameters in the default state. And when I click OK now, pretty quickly, we should now get those unclassified points to look to be classified as ground where appropriate. And we can see, of course, we've got a little bit of residual non-classification here from that original overlap kind of corridor where we've got some buildings and some vegetation. We could then return and do some automatic non-ground classification or things of that nature. But for our purposes today, I think that that's a good demonstration of some of the lesser known LiDAR filtration tools.
Yeah, that little strip of unclassified there really is a good visual to drive home that point. I hadn't noticed that when we looked at this data before, but.
Great. Anything that I left out major, Jeff? Or
I don't think so. I think you hit everything we had talked about there.
great.
We have just about 15 minutes left. So go ahead and move on. I'll talk through a couple workflows now and give your voice a break, Nate.
Thank you.
And we're going to look at some vector LiDAR terrain type workflows here with our next two examples to look at some ways we can kind of work with vector data in conjunction with our LiDAR point clouds. So what we're looking at here is a workspace. This is actually downtown Portland, Maine, so near, not too far anyway, from the Blue Marble headquarters. We have some imagery. We have some building footprints here. Let's make those stand out a little bit more. So I'm just specifying a color for these so we can see them a little bit better. Okay, there we go. So our building vector features. And what we're going to do, so if we look at these building features in relation to an existing terrain surface, we'll see that these building features don't have any sort of elevation associated with them. They're sitting right at the base of the structures as essentially a footprint, where in this scenario, and actually how this data was created and where this project stemmed from, the city wanted to have 3D vector models of just the heights of the buildings. And so that's what we're going to do here. To start that process, we're going to return to the original point cloud. And if we take a look at any point here, we'll see they have a variety of attributes associated with them. However, one thing we don't know for a given point is its height above the ground. And obviously that height value is what we would want to represent a building. So as Nate showed us earlier, using the height above ground color option, we'll quickly also calculate a height above ground attribute for a given point. Now, the reason I'm doing this is because what I'm going to do now is I'm going to use these height above ground attributes to create a surface. So rather than representing what we might see as traditional elevation, this is going to represent height above ground, although it's done very much with the same elevation creation process. I'm just going to choose to use the height above ground value. I'm going to run an average value here. The reason I'm doing that is just so that, if the top of a building has an HVAC unit or maybe a cell tower or radio antenna, we're excluding those because we just want a flat building surface for this scenario. And then once this is created, we can apply the information from the terrain surface right to those vector features to give them a 3D component. So I always like to see my vector data on top of my terrain data. So I'm going to select my entire vector layer. And then from the analysis measurement menu, I'm going to choose an option here called calculating elevation and slope statistics. So this will get calculated for every feature that I have selected. The result of that then being, let's take a look at a building. This vector feature now has all of the information added to it. Specifically, what I care about is the height above ground. Now, if I want to model this, clear my selection, the only thing I need to do is just adjust how this vector layer is referencing height. So from the layers options, under the elevation tab, by default, we want to get our height from the height attribute. In this case, we are going to use the average elevation, I believe it was. I feel like I may have in my steps here missed a step, so if these don't line up, we will know that I did miss a step. Let's turn off the other layers. There we go. And okay, that looks good. And so what we have now are three-dimensional vector features with the height elevation that was originally derived from the point cloud. Applying that to these vector features makes them three-dimensional, and these can be exported to any supported 3D vector format. So however you need to use these features, they now can be used and will be three-dimensional. And so we just talked about, in this case, making vectors three-dimensional from our terrain. Now we're going to look sort of at the inverse of that, and we're going to make a terrain surface and reference elevations, this time from a vector feature. So let's switch workspaces here. What we're looking at is a lake, or I guess technically this might be a pond. I forget the name of it. This is also in Maine, near our headquarters. Some reference imagery and the outline of the pond. Let's reorder those a little bit. There we go. So we have our pond and we have our point cloud. Now, generally speaking, when we are modeling some type of terrain surface and we have the ability to also model the water or a water body in the region, we generally want that water body to be flat on the terrain surface. But if we take a look at this, so just draw a profile across the pond, we'll see that this is the surface of this water body, right, is represented fairly unevenly. Very common with LiDAR. We're going to talk about a very easy way to fix it. Another thing we'll notice is that we also have all these sparse little, probably incorrect ground points in or on the lake surface as well. And we don't want any of this to impact the creation of our terrain surface. What we're going to do is we're going to calculate an average elevation for the surface of the pond. We're going to apply that to the vector feature and then enforce it when we create a terrain surface. First though, I will just go ahead and create a surface as is. So we haven't adjusted any of our elevations yet, but we want to take a look and see what that looks like, right? And look how choppy our water, like we don't expect a water surface to look like this. We want it to be flat and smooth. And so what we're going to do is, using the pond as a reference, I'm going to select all the points in the pond. Then what I can do is create an average point. We'll just call this average. This point is in the center of the pond and represents the average elevation. Let's take a look at that, of the feature. So that's the average elevation of the pond. One of the neat little vector pieces of functionality in Global Mapper is the ability to copy attributes from one feature to another. And so in this case, what I'm going to do is copy from the point to the area. So now my pond has the same elevation as the point, which is again averaged from the point cloud. So we've taken that information, added it to our pond, and now we will use both the pond and the source LiDAR to create a terrain surface. We'll call this our flattened surface. Make sure we filter to only ground. And now we'll see that when we have a vector layer selected as part of our terrain surface creation, we have this option here to use my 3D area and line features as a break line. And so in this case, we're just going to keep a very small edge here. You could always expand and enhance your edge. You know, that's useful if you're working with a very narrow strip, maybe a small stream or road or something like that. In this case, we'll leave that as is. And now we have just a much smoother surface of that fixed elevation compared to anything not flattened. So I can look at this simply by toggling one layer on and off. I could use the image swipe tool. That allows me to swipe back the topmost layer. I could even take a look in the profile view, and we'll notice over the pond, we can very clearly see the two different surfaces. But once we get back off the water on the land, there's no difference because we didn't change anything there. So we can zoom in and even more clearly see, measure that distance, and otherwise work with this information. So, you know, we use hydro flattening today for a body of water, and very often we talk about it for flood analysis and flow analysis. It can be used in site planning. Maybe you're, you know, flattening a building site or a highway ramp, or, you know, drainage culverts in a urban development. It has a wide variety of uses, even though we just call it hydro flattening.
And we use we do hydro flattening in the trainings too, but I think the pond polygon in the training has that elevation attribute already added to it. So I think this workflow actually came from a user in the training who asked, you know, well, what if we don't have that elevation attribute already? So this is really handy. So I hope that user is in attendance today. If not,
yeah,
this will be on the YouTube channel, so for posterity.
Yeah. All right, Nate, why don't I send it back to you? You want to tell us a little bit in more detail, talk to us about the path profile?
Yeah, sure thing.
All right, so we need to get you back to this workspace. Is that correct? Yes.
I think we want Portland. Yeah, there we go.
There you go.
All right, great. So we're coming up on the end of time here, so I might do a little bit of a
if we go just a little over.
Just a little over, yeah. I'm just gonna, I'll probably skip the well, no, I'll just go through it and then
Yeah.
let's see where it goes. So let's go ahead and look at our City of Portland point cloud once again. We did a couple of point reclassification tips and tricks in the 2D view, but another really handy way to do point classification or reclassifications and things like that is going to be in the path profile view. So gave a little preview of some automatic ground classification. I think our points in this one are already, we should have some ground classification already. Yep, looks good. So I'm just going to do a really quick, crude building classification. Again, just using the default settings here. This is the segmentation method. So essentially, it's just looking at minimum height above ground is how high above a ground point do those non-ground points have to be classified as either buildings or vegetation. I'm not going to classify vegetation in this case. We're focusing this portion on building classification. Neighborhood range, so looking at defining the region around a point that's determined to be part of a surface like a wall or a roof plane. And then segmentation works on point clusters. So we're basically telling it how big a cluster of points, how many points need to be in that cluster for it to be classified, and then basically what is the distance threshold for points to be considered part of one cluster, maybe another cluster. So just really quick, again, we go over that in the trainings. We don't need to talk about it too much here. I'll just leave this in the default settings, and we should get our points, our building points classified. But you know, usually it's going to depend on the characteristics of your point cloud. You'll have different densities, different terrain characteristics like slope and relief. So generally speaking, just running it in the default, you're not going to get every building point classified to a T. But you might get close. So sometimes it might be more conducive to automatically classify again and change up your parameters a bit. But other times it might honestly just be easier to manually reclassify some of those points. And so for that, yeah, we can see, looks like most of our buildings came through. But what we can do now is go to our path profile view and just have a look at that. I think that I want to say that this building right here is Portland City Hall. I might be wrong about that, but we'll find out soon enough. First thing I'm going to want to do is increase the width of that profile. Right now, that's only about 1 meter, so maybe we'll say about 20 meters. Make sure we get, you know, at least a solid chunk of that, and we can see that in the 2D view as well. Oops, that's the one I want. That our profile line is a little bit wider now. So what I'm going to do is dock this path profile window right here. And we can see, for example, that we've got, looks like a building roof plane here, but where the wall might not have been classified. So most of those manual, or all of the really important manual classification buttons are going to be included right here in Path Profile, as well as up here. But for users who are going to be doing a lot of this manual classification and reclassification, it can be a little bit cumbersome to have to keep clicking on those buttons. So one thing that can be very helpful to do is to just set up a quick little keyboard shortcut. So I'm going to set up my shortcut keys here. And in this case, I've just got some unclassified points and I want to be able to really quickly classify those as buildings. So I'm going to find that command down here in the list. It should be down in the L for LiDAR. Yep, oh, went too far. And we want LiDAR classify selected as building. And you can select any of the keys that are down here in the drop-down list. I'm just going to call that F2, and I'm going to add that shortcut. So now when I press F2, all of our selected points should classify as building. We've got a couple of different selection tools here in the profile view. The main one is probably just this click and drag, basic selection. You just click and drag and you get a nice box to select points in. But sometimes if you're working with a forested area or you've got some other surface features that you don't want to include in the selection, you can draw a little bit of a more kind of detailed and vertexed, if that's a word, selection polygon here. May have just made that up, but that's another option as well. And in addition to this, I mean, we've got some vegetation here, so it might not be the most conducive tool, but if we wanted to grab everything that were above, for example, this line of ground selection points too, we can grab this tool, which is just, as the name says, select all of the LiDAR points above a line. So I can just go ahead and click here, and as the tool kind of gives you a sense, basically everything that's between those two vertical selection lines, as well as the kind of baseline that I'm defining now with my cursor. If I close that, it should select everything above that. And now, again, really quickly able to reclassify those. I'm going to test out F2, see if that works. Yep, looks like it's asking me if I want to classify those as building. I'm going to say yes. And now when we clear that selection, we should see that all those points now are classified as building points. So handy way to do that in path profile that might not be as apparent, looking at this in the 2D view where from above, it looks like the entire building, whoops, I went a little too far there. Looks like the entire building was classified correctly, but we're just, from the 2D view, that nadir perspective, we're just looking at the roof, and the roof, remember, looked like it came in well, but you might have some walls, or I think this building here might be like a parking garage or something like that, where again, not all of those points are necessarily going to be captured in that automatic building classification. So that can be an instance where doing some of those manual LiDAR reclassification with maybe some keyboard shortcuts, if you're doing this quite a bit, that might be a helpful approach as well. So something to keep in mind if you're doing some LiDAR reclassification, which based on our poll at the beginning of the webinar, sounds like quite a few people do.
Yeah, that's great. Thanks, Ned. I always find myself doing a lot of work in the profile tool as well, just because it lets us do, so much, right? From one tool
Right.
in terms of some of that manual editing.
Helpful to have those different perspectives as well.
Yeah, absolutely. So I think before we let everybody go, we'll take a look at one more quick little exercise because it will take less than a minute. We're going to come back to Devil's Tower here. And, we talked about a little bit now looking at all of our point clouds in 3D view. We made some 3D vector features. But what about the scenario where we need a 3D mesh or a 3D model from our point cloud? That can in fact be done very easily. I'm going to go ahead and select just a small subset so this doesn't take forever to run. And I can then use the mesh creation tool to build a three-dimensional mesh from the selected points. And we can define things such as, some spacing and detail settings in here. I'm not going to get into those settings now. But the result of this process then is what will be a 3D mesh when this finishes. This mesh object then will, in this case, be colored based on how I have my LiDAR displayed, and so that will be with the RGB values. Let's clear my selection. And as I zoom in, let's see if I zoom in a little bit here. If I can get close enough, we'll even see the faces that make up the mesh. I may have to zoom in real far for that, so we'll skip that now. And instead, we'll go ahead and take a look at this mesh in 3D. So now we have a full 3D mesh or model derived from the point cloud. And now some of you may be familiar with creating these as part of the photogrammetry pixels to points process. In this case, this was not a photogrammetric point cloud, but we're still able to get a nice detailed mesh right from that product. Okay, I think we have kept everybody long enough. What do you think?
Yeah.
So thank you everyone for joining us today. I know we threw a lot at you. I hope it inspired you to go dig around the application a little bit more, and maybe take a look at some of our other documentation and training. We may have a few questions we didn't get to today live. Again, you will at some time in the not too distant future get a written answer to those. You can always email our sales team, the first email listed here, or our tech support team, the second email listed, with appropriate questions as needed. Nate, thanks a lot for joining me today. It was great to have your help and knowledge and skills for all of these demos.
Yeah, thank you. This was great, and thank you everyone for coming as well. Obviously.
Okay, take care, everybody.
Bye.
Bye.